We are working related rate problems, and we're going to be looking at this particular problem here, and pretend this is a happy face right here, someone walking along a path. Um, Sometimes you hear it as a point moving along the curve here, but anyway, and I think he's going to be walking in this direction, which means that if he's walking in this direction along the path, my dx over dt is going to be increasing, right, positive. But as I move downward, okay, what's happening to my y value? It's decreasing. So my dy over dt would end up being negative if I'm moving in this direction here. Right. So here's the equation that describes that path. And this is what we're given. We're given a dy over dt. Now you notice that says negative 10. I'm not going to be using any units here like feet per second or centimeters per second. It's just going to be, right, units per time, whatever. But I'm just going to kind of leave those off right now. And then it says, when x is equal to 1, right, what is dx over dt? So that's the big question. So all we do is take the derivative of this, remember, with respect to t. So the derivative of y is just 1, and then we write dy over dt. I'm not writing a 1 in here, right? 1s are kind of invisible when they're multiplied by something. But okay, so the derivative of x minus 3 squared, quantity squared, so we take the 2, we bring it out front. We rewrite everything in parentheses and subtracting 1 from the exponent, and then we write dx over dt outside of it because we've taken the derivative of it. Now, normally we'd take the derivative of what's inside the parentheses here and bring it out, right? Well, the derivative of x is 1 and that's 0, so right, there's a 1 out there, but we don't write it in. And now we're going to take the derivative of this part here. So we take the 2, we bring it out front. 2 times 3 is 6. Rewriting everything in parentheses and subtracting 1 from the exponent, like we did. And once again, right, no need, but you're technically taking the derivative of what's in parentheses and bringing out, but that's just 1. But then once we take the derivative of this, consider this to be one single function, then we write dx over dt next to it. So now that we've taken the derivative with respect to t, now what we need to do is just go in, plug in everything that they give us. They gave us a negative 10, so we're going to replace that with negative 10. And we're going to replace the x with a 1, and then we're going to solve for dx over dt. Alright, so we just go ahead and plug everything in. I think what I did here was I went ahead and factored this dx over dt out. As you can see here, I just pulled it outside and then went ahead and plugged in our 1 for our x and simplify everything down. I don't know why I repeated this twice, who knows. But whatever, I was probably tired that night. But let's see. Okay, so we get down to here, we just do the arithmetic, we get negative 10, and therefore dx over dt is equal to 1. So we notice that this is positive, right? Because remember that we were moving in the x direction. So dx over dt is 1. Let's go back to the graph real quick. Alright, so when x was 1, right, we said that dx over dt, that's what we were working out, was actually 1 unit, let's say, for example, I don't know, per second or something. But it's moving in this direction 1 unit per second. But in the y direction, at when x is equal to 1, it's actually moving 10 units, let's say, per second. And remember, it was negative, so that means it's coming downward, right? It's coming downward or decreasing towards the, however you want to look at this, towards the x-axis. But so it's right in the dy over dt, it's increasing much faster than it is in the dx over dt direction. I guess that's the way you want to look at that. But anyway, it's fun. And we're finally doing something with our calculus here. Which I know people like to work some really concrete problems so they can better understand what's going on. But let's move on to the next problem.